Hello, esteemed judges and selectors. This is a quick tour of my prototype called Ocean Analytics. It's for Smart India Hackathon, problem statement number 25041. It's called AI driven unified data platform for oceanographic fisheries and molecular biodiversity insights. So let's start from the beginning. This is a register tab. The thing you should notice over here is the roles for students, scientists, and admins. So only scientists can upload data to keep the data standardized. So only students can only analyze the data. So the data becomes very rigorous and good. Let's go to the login page with and use a scientist credentials to log in. So I can give you a quick tour of our prototype. This is our home page, a dashboard that displays the species count already in our database and the hotspots they are found in. For my small prototype, I have only taken the oceanographic data of the Arabian Sea for the year 2022 and the species biodiversity data of 2019 for Yemen Basin because that was the only data available to us. Now, back to our prototype. We have a custom water quality index algorithm that calculates water quality index based on environmental factors we have in our database such as chlorophyll, oxygen dissolved, sea surface temperature, current rates, etc. Now below that we have a species distribution map. So let's say we have selected a species such as Sardellina longiceps and our model basically shows where this particular species was found. So if you click on that, we will see the abundance it was found in, the location it was observed in, and observed time. Also the name below that, and this is true for all species. Like if you change the species itself, as you can see, abundance changes, the time changes. Okay, as you can see, yeah. Below that, we have a single variable graph, ocean variable graph comparison. So basically, when we select two particular variables such as sea surface temperature and time, okay, time, we can see a graph forming for the year 2022, and if we hover over that, we can see the timestamp and the sea surface temperature over here by time. Okay, so let's say we don't want time, we want salinity. So as you can see, this is a sea surface temperature versus salinity graph. You can see the sea surface temperature versus salinity for Arabian Sea. Now we have a multivariable graph over time. So these basically shows data such as sea surface temperature, salinity, dissolved oxygen, chlorophyll versus time graph, multiple variables on one graph for the year 2022, like I said. And if you hover over any part, we can see the change of data. Now let's jump to our upload tab. So thing to notice over here, we have decided to meta class the data sets. Instead of uploading all and every kind of data, we give the user the task to select what kind of data it wants to upload, such as oceanography, fish observation, taxonomy data. So basically, taxonomy data, metadata gives metadata tagging to our fish observation and species, such as family, genus, etc., etc., and eDNA sequences for a particular species. So let's say I want to upload an oceanographic data, and I select chlorophyll for the year 2022. So basically what it does is we have a data lake that takes unstructured and all kind of data such as oceanographic data, fish observations, eDNA, and then it gets transformed through an ETL pipeline that recognizes this data. We have a smart recognition system that recognizes what kind of data it is based on various names like chlorophyll can be CLR or chlorophyll itself in the CSV files. So basically, what our identification model does is identifies which kind of data it is and uploads them to their particular tab through an ETL pipeline, first through an ocean lake, data lake, sorry. Then we have our analysis staff, the MVP of our project itself. So let's say we select Sardellina longiceps again and run hotspot analysis on it. So what it will do, so we have multiple algorithms like key cluster, random forest regressor, isolation forest, etc. That takes these data and also custom water quality index indicator and takes these data and predicts stuff like catch prediction. This is in quintals. Anomaly detection. The anomaly in this particular area is zero, so no anomalies. Like it also shows if chlorophyll is high, oxygen dissolved is low, things like that. Water quality index, it calculates, like I said, calculates water quality index based on the data set we have, and these also it also shows the kind of data we have for this particular place, like sea surface temperature, salinity, chlorophyll, oxygen dissolved, etc. What I want to implement on this project further is an LLM model and an orthographic recognition system, which is work in progress. Basically, what it'll do. So let's say some scientists have a question that if sea surface temperature rose by 2 degrees Celsius on this particular place, how will Sardinida longiceps biodiversity will be affected? So basically, what this LLM model would do will take this data, process it, and answer your questions like a text bot. And an orthographic recognition system that basically, if we upload a fish bone dataset and ask him what kind of fish it is, it basically recognizes what kind of fish that is and tells his name, etc. and where it was found based on all based on the data we already have in our dataset. Then we have our about section and credit section. Basically talks about our project further. For further details, I would like our esteemed judges to go through my PPT. Thank you. Have a good day.